Hi, welcome to this channel, GCP Exam Ready. In this series we're going to go through the Associate Cloud Engineering exam and we're going to go through everything you need to prep for it and pass it. In our last couple of videos we've given introductory videos to all the concepts. In this video we're going to dive deeper into the compute resources. As we said previously, the compute resources are virtual machines, managed Kubernetes clusters, and serverless computing. If you're not aware of this, check out my last videos to see what this is all about. Let's first start with virtual machines. Virtual machines are a type of infrastructure as a service, and they're found under Compute Engine in the console. To create these virtual machines, you have the option of configuring them from scratch, but you also have the option of using what we call images so that your configurations are much easier and your virtual machines can be alike. Let's have a look at what these virtual machines are. Virtual machine images are instances that have OS, libraries, and code attached to them. You can have Linux and Windows, and you can create your own, use open source ones, or buy third-party ones from Google Marketplace. How can we create these virtual machines? You can create them from a boot disk. You can also create them from another image using something we call snapshots. By now, you're probably wondering what snapshots are. Snapshots are created from images. You can think of them as exactly as screenshots on your phone. So these snapshots are created from images or virtual machines, and then they can be used to create more images, virtual machines. Why would we use snapshots? Because we want to make the configuration process simpler. If you're planning to use the same OS, libraries, and sections of code, you'd rather have a snapshot that you can implement instead of having to import all of these separately. We've been through roles previously, but in this video we're going to go through the user privileges, aka roles, that are specific to who can create a VM, what can they do on the VM, etc. So we have 4 types of user roles when it comes to virtual machines and creating them. We have Compute Engine Admin, who has full control over the compute resources, and this person can create, delete, and change instances. Then we have Compute Engine Network Admin and Compute Engine Security Admin, which are exactly as they sound. One is in charge of the networking resources on GCP, and the other is of the security resources on GCP. Network admin can set which network the VM is a part of, while the security can set firewalls and HTTPS. Then we have Compute Engine Viewer. This is somebody who can see only a list of Compute Engine instances. Can't change them, can't see what's inside them, and can't see any configuration, anything else, just a list. When should we ideally use virtual machines on Compute Engine? It can be quite difficult to differentiate between the types of compute engines and when you should use what. We'll take this video to clarify that so that it's more easy for you to classify which options are correct and which ones are wrong in the multiple choice exam. We want to use virtual machines when we want complete control over virtual machines. We want complete control over what we're using the compute resource for, which means we have to configure a lot more, we have to make a lot more policies, and we have to give more roles and access. Or less, depending on how many people are in your team. Next, we'll have a look at serverless computing, which is platform as a service. This divides into cloud functions and App Engine. App Engine further divides into standard and flexible. We'll also look at that in the next couple of minutes. App Engine. When should we use App Engine? Let's first clarify that. We want to use App Engine when we want to focus on the application instead of what the VMs have to do. which means that we want less time spent configuring the virtual machines and more time working on our code on the application. That's what makes it serverless. You have way less configuring to do. GCP already does that for you. Serverless computing is common between Cloud Functions and App Engine. If you're not sure what we mean by serverless, check out one of my last videos, you'll definitely find out. Now, I'll give you a quick recap. Why is it serverless? It's serverless because you only have to do the basic configurations. You don't have to configure every aspect, and you don't have as much control with it as you would with a virtual machine on Compute Engine. We also have structures for App Engine, just as we did previously for virtual machines and for Kubernetes. We also have structures for App Engine. I'll give you a brief description in this video. There'll be a future video dedicated just to this. In App Engine, we have services, aka functions. Each service does one specific function for your application. You can have many versions, just as you would when you're deploying an app to a mobile or whatever app you're deploying. So you have many services with one or more versions per service. So how can we determine the number of instances? You have two types. You have dynamic instances and you have resident instances. This is important in the exam. Dynamic instances allow you to use autoscaling. We've gone through this before. If you're not sure what autoscaling is a setting which enables you to increase and decrease the number of virtual machines running on your application depending on traffic. Resident instances, these just run continuously and are set. Now let's have a look at the difference between App Engine Standard and App Engine Flexible. As mentioned before, there are two types of App Engine. The name kind of gives it away. You have App Engine Standard, which is a pre-configured language-specific runtime sandbox. You have two types, which means you have two generations. You've got first gen, which supports Python 2.7, PHP 5.5, Go 1.9. You have second gen, which now also supports Java 8, Python 3.7, a later version of PHP. In addition to that, Node.js 8 and Node.js 10, and a later version of Go. Why would we use App Engine more Flexible instead of Standard then? Because it gives us more control. App Engine Flexible uses containers, mostly Docker containers. These are small packaged containers, and you've got an option of using Autoscaler if you want to. Plus, with App Engine Flexible, you have the option to add extra libraries and tools from third parties. By now you're probably wondering and thinking this sounds a lot like Kubernetes Engine, but there is a difference. On Kubernetes Engine, you have to manage the health of the clusters. You have to do that manually, which means that your DevOps team has to carry out these health checks when you need them to. Whereas on App Engine Flexible, GCP does that for you. It's serverless. You don't need to do as many configurations, and you don't need to manage the health of the containers. It's done for you. If a container is unhealthy, you're alerted, and it's shut down and a new one is created, depending on the policies you've set. Now, let's move on to Cloud Functions, which is also a platform as a service. Cloud Functions is a little different to App Engine in the sense that it is not specific. You've got a single purpose code that responds to an event. Whenever in a question you see event response, automatically think Cloud Functions. This is serverless. Your cluster health or container health is managed by GCP. Runs with Node.js, Node.js 8 and 6, and Python 3.7. The difference is each function is isolated, which means that they can't be dependent on each other. each function you create has to be independent of every other function. But on the plus side, you can have multiple functions running at any time, which makes it beneficial for if you want to look at, for instance, folder uploads, or you're waiting for documents to upload, etc. We'll look at these scenarios later on to give you a better example. Finally, let's have a look at Kubernetes engine. We've gone into quite a lot of detail in previous videos, and if you don't remember what the structure is, I strongly advise that you have a look at that video again, which is the introduction to Kubernetes engine. Now let's dive a little bit deeper. Let's have a look at what that is. We said Kubernetes engine, you can create virtual machines either individually or through instance groups. You deploy the cluster, then you admin the cluster, you add policies such as autoscaling, and then you continuously monitor the health. For the structure of Kubernetes, you have two types. You have a master node, and then you have more general nodes. When we say node, we mean virtual machine. The master node, as the name suggests, manages everything in that cluster. We'll have a look at what it does in more detail in further videos, but for now, I just want you to have a general overview of what this Kubernetes engine looks like on a high level. Kubernetes engine deploys containers in groups called pods. This is extremely important. These pods have the same network, same storage resources, same IP address, and the same port space. This is very vital for the exam. We also have something called an eviction policy, which means that if your pods are starved of a resource and they can't perform as they should anymore, they're shut down and new ones are created, which makes this highly available. Bringing me to my next point, high availability. Now that you have identical copies of pods, which we call replicas, if a copy of the pod is no longer functioning, the other copies can still carry out the job while that pod is being replaced. Groups of replicas are called deployments, which means that you can have deployments for managing different types of things depending on how many pods you need. That means it's highly available. If one of the pods fails, the others will still be able to respond. You have three types of deployment stages. You have processing, completed, and failed. They do exactly as the name suggests, so there is no confusion. Progressing means that you are in the process of deploying this pod or this group of pods, these replicas. Completed means everything is going well and you are now running. Failed means something's gone wrong, either your DevOps need to check it or this pod is being, or this replica is being regenerated. This has been GCP Exam Ready. I hope that this deep dive into each compute resource has been helpful to you. If it has, please hit the like button down below and the subscribe button. Leave any questions you have down below, and I hope to see you in my next video. Best of luck.